There we go. All right, good morning. This is A1 Algebra 2 CP. This is Tuesday, May 19th. Hopefully you're having a great morning so far, and hopefully it's about to get even better because we're going to be solving today more rational equations. I was just talking to you guys before I started recording and mentioning that this week we are going to just keep plugging away at equations. We're just going to keep going with more equations, more equations, more equations. And the reason why I decided to dedicate 2 weeks to solving rational equations, even though, yes, it's not like I'm going to be teaching you anything new today, but I want to focus on equations that have more to do with factoring, more to do with distributing a negative sign, more to do with tricky cases that kind of show up from time to time. And the reason being is that this stuff shows up quite often in pre-calculus, and these skills are used all the time in pre-calculus and calculus and other types of math. Even a class like discrete math, where you may be working with fractions, you're going to need to know how to do these least common denominators and put the fractions together. So it's important that you understand these equations. I think this is one of the most important topics that we do in Algebra 2, probably in addition to radicals and quadratics. So that being said, that's why I wanted to spend a lot of time on it. After that, we will spend a couple weeks just talking about some applications of rational equations, aka word problems. And then we'll probably have a wrap-up day, and we are rapidly approaching the end of the academic year, which is exciting. However, we're not there yet, so let's try to have a couple more great classes together. Let's do some great learning, and so we can end on a high note. All right? I'm up for it if you are, so let's go ahead and get going. Today, just like last class, I have 5 equations that I'd like to go through with you. If you have any questions while I am solving them, please feel free to just speak up and let me know. Don't be shy. I tried to pick out problems that specifically emphasize tricky factoring, or emphasize distributing negatives, or emphasize having whole numbers or variables and what to do with those. So hopefully this will give you a good sampling of problems to go off of. Next class, I plan on doing much of the same thing. And then after next class, we will have another graded progress assessment sent to you. Speaking of which, the one that was just due on Monday should be in Aspen very shortly after the classes today. I plan on getting that all set for you, and the answer key will be posted so you can check your work as well. All right, so that's my plan going forward. Hopefully that works out for you. If you have any critique or feedback or anything like that, you always know you can just let me know. All right, so without any further interruptions, let's go ahead and get started here with solving some rational equations. Let's just dive right in, and let's take a look at a couple more. Again, I wanted to dedicate a lot of time to this because I think this topic is particularly important. And also, if you have any questions at all, please just feel free to ask. Don't feel like you're interrupting or you're being rude or anything like that. Just please feel free to ask. Okay? So let's start with this first equation here. It's a rational equation. X over x minus 2 plus 1 over x minus 4 equals 2 over x squared minus 6x plus 8. Hopefully you're looking at that denominator in that rightmost term and you're thinking to yourself, factoring, right? I would hope so. I would hope we're thinking about factoring. So that's exactly what I'm going to do on this term. I'm going to break it down. We have x over x minus 2, staying the same for now, plus 1 over x minus 4 is equal to 2 over x minus 2 times x minus 4. That's exactly how you break down x squared minus 6x plus 8. You also get a little clue that that might be how it factors down, because if you notice, you have a factor of x minus 2 here and a factor of x minus 4 here, and you might be like, well, wouldn't it be convenient if we got x minus 2 and x minus 4 here? And not surprisingly, that is what happens. Okay, so now that I have that factored form, I can identify my domain restrictions. I can understand that x cannot equal 2 in this case, because 2 minus 2 would result in dividing by 0, which is bad. And also x cannot equal 4 in this particular problem for the same reason. 4 minus 4 would be 0, and we don't want to be dividing by 0. Now that we established that, we can go ahead and find our least common denominator. Here I have a factor of x minus 2, a factor of x minus 4, a factor of x minus 2, a factor of x minus 4. I need an x minus 2 in my least common denominator. That will make this happy and this happy. I also need a factor of x minus 4, so those guys don't feel left out. And now everybody's all happy. Okay? Now what I'd like to do is I'd like to convert all of those fractions. to be out of that least common denominator. So I would like my denominators to all look like this. Again, this is very similar to the problems we've done before. Same idea, trying to convert everything. I would love those denominators to look like this. Okay? And now we ask ourselves, well, what do I need to multiply this denominator by to make it look like this? Well, I need to multiply by x minus 4. That's the missing piece. So I'm going to do the same to the top as well. The numerator is x. I'm going to multiply that by x minus 4 in order to convert your fraction correctly. Okay? What do I need to multiply this by to get this? It's your x minus 2. We're going to take the 1 that's already in the numerator, multiply by x minus 2, you get x minus 2. And what do I need to multiply this by to get this? Nothing at all. It's already the same, so throw a 2 up there. Okay, because the 2 was already there. Now that your denominators all match, we can just focus on those numerators. We're going to do a little bit of distributing in that first term. I'm going to get x squared minus 4x. Here I got plus x minus 2 is all equal to 2. Any questions as to how I got to this point at all? Please, 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 if you have a question, let me know. All right, doesn't seem like it. So let's keep pressing on. We see that value of x squared show up. That's a great indication that we need to do some factoring. But before I factor, we of course need to set equal to 0. So that gives us x squared minus 4x, minus 4x plus x is minus 3x. My fault. And then if I subtract 2 to bring it over to here, I get minus 4 is equal to 0. That factors down now. We got x squared minus 3x minus 4 is equal to 0. Factors down to x and x. Looks like we need 1 plus and 1 minus, and I think it's going to be minus 4 plus 1. And so I get, in this particular case, two potential solutions, one of x equals negative 1 and one of x equals positive 4. Okie doke. Oh, yeah. Oh, yeah. I can already tell. I don't even need to hear it from you. I don't even need to see you type in the chat. I can already tell that you're bothered by this. And why are you bothered by this? Well, because we said that x equals 4 is one of our domain restrictions. X cannot equal 4 because it would result in dividing by 0. So therefore, this solution is extraneous. And we have but one solution to our problem. That one solution is x equals negative 1. Okay? So the reason I wanted to point that problem out to you to get started was the fact that it has an extraneous solution and that it's important to check for extraneous solutions. So that was kind of the focus of that problem. Questions about that at all? Any questions? No questions about that? We're feeling fine? Okay, now let me present to you a problem with the focus being dealing with whole numbers that are just chilling on the outside. We already said that we want to put them over 1, but this problem is kind of cool. It has a couple of them, so we're going to see how we deal with that. Ready? Let's try another example. How about 1 over x plus 1 is equal to x over x plus 1. Oh, sorry, not equal to. My fault. Plus. So we have 1 over x plus 1 plus x over x plus 1 is equal to x minus 2. Okay? Kind of a cool thing that you could do here if you so desire. Both of these denominators are already the same, so you could actually combine this and get just x plus 1 over x plus 1 and see what happens from there. But I'll show you actually, going forward how we can actually do this with our least common denominator. That won't pop up very often. That's kind of where you have the same denominator right at the beginning. So I don't want to get into that. I'll go more on, what should happen in general versus what happens in this one specific case. So first things is factoring the denominator. There is no factoring in the denominator. But what we can do is specify what x cannot equal. And we identify that x cannot equal negative 1. That's one of our domain restrictions, right? So now I find my least common denominator. Not much work to do the least common denominator here. We just need that factor of x plus 1, right? Notice I'm not even considering these things for my least common denominator because when we just see a variable by itself, we can put it over 1. When we just see a whole number by itself, we can put it over 1. You don't have to put it over 1 if you don't want to, but it's a helpful tip just so you can keep track of the fact that there is a denominator there and it has a denominator of 1. Keep in mind that you wouldn't put x minus 2 in your least common denominator because this isn't in the denominator. It's just an x by itself means it's x over 1. This is a negative 2 by itself minus 2 over 1. Okay, now you would want to convert everything to be out of that least common denominator. So what I'm going to do is I'd like the first thing to be over x plus 1, which it already is. That's nice for us. I'd like the second thing to be over x plus 1. It already is. That's nice for us. I'd like this to be over x plus 1, and I would like this to be over x plus 1. Notice we're converting every single term. There's 4 of them in this case. So this one's already the same. Notice the denominator already matches. This one's already the same. Again, notice the denominator already matches. This one, however, we do need to take the x that's already there and multiply by x plus 1. And this one, we need to take that minus 2 that's already there and multiply by x plus 1. Does everybody see why that's the case? Because we're just doing the conversion. Right? I want to convert all the denominators. I want to convert all the denominators. Now that I have that, we can go ahead and just focus on the numerators because all the denominators are equal. I get here 1 plus x is equal to, little distributing, x squared plus x, and then distribute. And a key thing to keep in mind here is this negative 2 is going to distribute to each term. A common mistake a lot of students make is that negative sign just either goes away or they only apply it to this first 2x here. Make sure that distributes everywhere, minus 2x minus 2. Okay, so be mindful of that. I have another problem to show you where the negative sign is sort of the key important thing about that problem. All right, now I see x squared. Again, that means factoring. And before you factor, you'd like to set equal to 0. So what I'm going to do is subtract x over to this side. I'm going to subtract 1 over to the right side there. I get 0 is equal to x squared. Here I get x minus 2x is negative 1x minus another 1x, so minus 2x, minus 3. Notice that allows me to factor nicely to x and x to make x squared, 1 positive and 1 negative to multiply to the negative at the end. And I think the factors I need here are negative 3 and positive 1, which gives me 2 potential solutions of negative 1 and positive 3. Look at that. There we go. We're happy. And of course we're not happy. What do you mean we're happy? How could we possibly be happy when we have this extraneous solution sitting over there, right? We don't like negative 1 because we just identified that our domain restriction is negative 1. So my one solution that works out is x equals 3. But again, the big point that I wanted to emphasize with this problem was the fact that we have these whole numbers and variables just sitting here. It doesn't mean that we ignore them. It doesn't mean that we discount them. It doesn't mean that we put them in the denominator. It means that just write them over 1, and then convert them just like normal. Does that make sense to everybody why that's the case? Hopefully. Feeling good? Making sense? All right, excellent. Like I said, one kind of cool thing in this problem, I'll point it out just really fast. One thing that you could have done is because coincidentally these two denominators are the same, you could have rewritten that as it's 1 plus x over x plus 1. Like, since they have the same denominator, you could have squished them together into one fraction. It's like saying that 1/5 plus 2/5 is 3/5. You just do the 1 plus 2 in the numerator. Same thing here. Same denominator. We'll stick those fractions together and get that that's equal to x minus 2. Well, this is the same thing divided by itself. So you could have said, well, any number divided by itself is just 1 instead of that 1 equals x minus 2, and therefore x equals 3. And you could have solved that problem in 2 seconds. Now, generally, that's not going to be the case. That's why I didn't want to be like, this is all you have to do, because that's not true 99% of the time. But it's just cool in this particular problem that if you notice, hey, these denominators are already the same, I could actually just stick them together and then notice it's just the same thing divided by itself. That comes out to be 1, and you solve your problem. The problem with doing that, so to speak, is that you wouldn't be able to identify this extraneous solution of negative 1. So that's why it's cool if you notice that, but it doesn't allow you to identify that, which is kind of a shame. All right, in any case, ready to move on? We got one more problem that I'd like to show you today. At least. If we have time, we can keep going, but I'd like to try to just, focus on getting one more problem done. All right, here we go. Let's do it. Let's do it. How about this? Ready? This one, speaking of which, this one I'd really want to emphasize distributing that negative. That's the point of this problem. Point of the first problem was to show you an extraneous solution. Point of the second problem was to deal with whole numbers and variables just by themselves. Point of the third problem is I'd like to show distributing negatives. I'd really like to emphasize that. I got 1 over x squared minus 6x plus 8 is equal to 1 over x minus 2 minus x minus 1 over x minus 2. Okie doke. So let's see how we're going to deal with this problem. First thing to do is definitely to factor. We see that bottom left term over there, the x squared minus 6x plus 8. Let's go ahead and factor down that trinomial to be x and x. Looks like we need two negatives to multiply to the positive and get that negative result in the middle there. And what factors of 8 are going to work? We need minus 4 and minus 2. Equals 1 over x minus 2 minus x minus 1 over x minus 2. Just like that. All right. Now I can go ahead and find my domain restrictions. We can state that, well, x definitely should not be equal to 4, and x definitely should not be equal to 2. Was that the case in the first problem we did? Oh, look at that. Coincidentally, same domain restrictions. Kind of cool. But anyway, that's our domain restriction to start out. And again, the reasons for that is because plugging in 4 would result in dividing by 0. Plugging in 2 would result in dividing by 0. So be careful not to do that. Now that we identify those, we can convert everything to have the same denominator. My least common denominator is x minus 4 times x minus 2. Because I need a factor of x minus 4 to make that happy, and I need a factor of x minus 2 to make that, and that happy. Notice if I just made my least common denominator x minus 2, this would be happy, this would be happy, this would be happy, but this guy would be like, wait a minute, wait, what are you doing here? I'm x minus 4. I can't fit into x minus 2. So we need to accommodate every single piece. Okay? And remember that when you have a binomial like that in the denominator, it is treated as a singular factor. Now, we can go ahead and convert all of these things to have that same denominator. Notice I just right away instinctively left that one the same. It already is the same, so we don't really need to touch it. This one I would like to look like x minus 4 times x minus 2. So what do I need to multiply this by in order to make it look like this? It's x minus 4 times 1 is already x minus 4. Now, this denominator, I'd also like to look like that. So what do I need to multiply this by to make it look like this? The x minus 4 is what's missing. So I'm going to take the x minus 1 that's already there and multiply it by x minus 4. Hopefully that conversion process makes sense, right? You're pretty much just advancing from one term to the next term to the next term, and you're asking yourself, what's the missing piece? What do I need to add in there? All right. Now that we have that, I can go ahead and just focus on the numerators because the denominators are already the same. Notice what's going to happen with this negative sign. I kind of warned you about it at the beginning. Watch what's going to happen. I get 1 equals x minus 4 minus. I need to distribute this together. That's the x minus 1 and the x minus 4. And then take the opposite of the entire quantity in the numerator. Okay? So I'm going to distribute this x minus 1 times x minus 4 and then take the opposite of the whole thing. That's why I opened a parenthesis here. We're going to get x times x is x squared. X times negative 4 minus 4x. Here I get minus 1x plus 4. That's your first down or inner last, right? And again, that negative sign, when you see a negative sign on the outside of a fraction like this or a rational term, it means it applies to everything that's in the numerator. It's the opposite of all of this stuff over this stuff. All right? That's a super important idea, so that's why I wanted to make sure I emphasize. Now, I can go ahead and combine my terms, distribute that negative. I'm going to get 1 equals x minus 4 minus x squared. Let's see, minus 4x minus 5x. So, minus 4x minus 1x is minus 5x. The opposite of that, plus 5x. The opposite of this, minus 4. All right. We see x squared show up. Again, indicator that we need to do some factoring. Before we do, we need to set equal to 0. One other observation that I would make about this problem is I would notice that the leading coefficient of x squared is currently negative. That's generally not ideal. We don't want to have a negative leading coefficient of x squared when we do factoring. If you notice in all of the factoring problems we've done really throughout the year, we haven't seen a negative x squared show up at all because it really just makes your factoring unnecessarily more complicated. If possible, let's try to convert everything over to this left side. Even though you might be like, oh, there's a lot of stuff on the right, let's just move everything to the right. Since x squared has a negative leading coefficient, it's more beneficial to try to move everything to the left. So that's exactly what we're going to do. First, we're going to combine some like terms, so that's a little easier. X plus 5x is 6x, so I have my negative x squared plus 6x minus 4 minus 4 minus 8. Okay, let's move everything over to the left to make that coefficient of x squared positive, because if I add x squared over there, I subtract 6x over here, and I add 8 over here, we're going to get that x squared minus 6x plus 9 is equal to 0. Hopefully, again, you see why that's beneficial, because now x squared has a positive leading coefficient. Now we can go ahead and break it down. I need x and x to make x squared. Looks like I need two negatives here, and I think it's just 3 and 3. And so we get two of the same solution in this particular case of x equals 3 and x equals 3. Okie doke. So this problem does have one solution. That one solution is x equals 3. And again, you may remember back when we dealt with quadratics, something that shows up when, or with polynomials rather, when you have a solution that shows up multiple times, you could say that that solution is a double root if you so desire. Or another term that's used oftentimes is you say it has a multiplicity of 2. Not necessary in this case to indicate that, but what is necessary is that we just make sure and we check that it's not an extraneous solution, which it most certainly is not. Okay? So that's a pretty involved problem. This is definitely a problem where I would say this would probably be about the hardest it gets in terms of distributing the negative, where there's a lot of potential for mistakes with that. In terms of factoring over here with the negative x squared, where you have to recognize, ooh, we got to move that over to the opposite side of the equation. And then just setting up the least common denominator in general, which involves a fair bit of factoring. Does anyone have any questions at all about that? Even tiny questions, even little questions. We've got a couple extra minutes. Going once. Questions going twice. Alrighty, questions sold. So we're ending a couple minutes early today. I suppose that makes up for the times that I've kept you a couple minutes later. So I appreciate that. But of course, I'm going to get back. I want to emphasize the fact that, again, next class, we are going to be solving more rational equations. The rational equations I'm going to show you next class, though, are not really going to be too similar to these in the fact that there are going to be some special cases. The special cases of rational equations that can give no solution. I don't think we've seen one of those yet where there's just straight out no solution. And rational equations in which you can get infinitely many solutions. So those are the two styles of problem, in addition to probably a normal one. Those are the two styles of problems I'd really like to emphasize. There are special cases in which you can get no solution. That really just is if both are extraneous. Or you can get infinitely many solutions, where any number will actually make this work out. So I'm going to show those to you next class. I'm looking forward to that. After that, again, we will have our PA. It will be due next week. And then we'll move into applications. All right, ending a couple minutes early today. Thank you so much for your attention and focus. I hope you have a fantastic rest of your Tuesday. I'll post some practice work on Google Classroom, so please make sure you get that done. The answers will be provided for you as well. So I will see you on Friday. Enjoy the rest of your week. Have a great day, everyone. Take care. Paul, have a great day.